Okay, Algebra 1, this video lesson covers the concept, a new concept of a system of linear equations and how you can solve that system by graphing it. It's from chapter 7.1. And here's an example of a problem that you might encounter. Go ahead and use graph paper and ruler, or grab some so that you can follow along with me. We're going to figure out where these two lines cross. Now keep in mind, we just finished the test on chapter 5, so you should know that these two equations are going to create lines, and you should be able to graph those lines. I'm going to separate them by color coding. The first one I'm going to consider green, the second one blue. And there's my green line. I made it by, whoops, don't need to be grabbing that. Hang on. Made it by identifying the y-intercept at positive 2 right there, and the slope from that point is a rise downward, a negative rise of 2 and over 3. So down 2 from that intercept and over 3. There's another spot, and I draw a line between the first spot I made here and the second one there. I draw a line through, and that's my line, my linear equation, my line that it corresponds to this linear equation. The blue one is this line. And again, y-intercept at negative 4 down here, slope of 4 over 3, go up 4 over 3, and there's my blue line. Notice that the key point of this is to find where they cross. They seem to cross right there. It would appear so anyway. The coordinates of that point are 3, 0, but we can always check to see whether or not I'm right about those being the coordinates of the cross point. Instead of calling it y equals negative 2/3 x plus 2, I can put placeholders in for y and x. And I can do the same thing for the blue equation. And in place of those placeholders, I can put the 3 and the 0. Remember, the 3 goes in the place of x, so in this equation the 3 goes here for the green one and here for the blue one, and the 0 comes over here. And I can double check and see whether or not the arithmetic works. Is it true that 0 is equal to negative 2/3 times 3 plus 2? Well, double check if you need to. Negative 2/3 of 3 is negative 2, and negative 2 plus 2 is 0. So that one worked. 4/3 of 3 is 4, and 4 minus 4 is 0, so that one worked as well. So this is the right set of coordinates. 3, 0 is the solution to this system. Okay, so what is a linear system then? A linear system is simply two lines or more. That's what a linear system is. Once you have two lines, what we're going to be focusing a lot of our attention on is finding the place where those two lines cross. So here's one for you to try. Hit the pause button when you come back. I'm going to show you the worked out solution to this system of linear equations up here. Okay, I'm going to assume that you've paused, that you've obtained graph paper and a ruler, and you found the cross point for those two lines. So here is that cross point. It's at 4, 6. And you can do just like I did, double check, and you will find that that is the accurate intersection, the accurate solution to this system of equations. So when would you really use this kind of skill? Well, here, look at this story. Hit the pause button, read this paragraph to yourself, and after you've done that, then look at these two models of equations, these two mock-ups of equations. When you're done, I'll talk this through. Okay, I'm going to assume that you did that. I'm going to consider apple juice X and orange juice Y. And what this is saying is that I bought a total of 12 bottles, and that's where this 12 came from. And some of them were apple juice and some of them were orange juice. And I've decided to call them X and Y. I could have called them A and O, or any letters that made sense. The second piece of information I have is how much what the price was for those. The apple juice was $1 each, and the orange juice was $1.50 each. So my first equation, the blue one here, is what I said at the very beginning. All the apple juices and all of the orange juices combined made 12 bottles. In other words, x plus y equals 12. But my second equation is a little more detailed. It says 1 times x, in other words, the price, $1, times all of the apple juices. Remember, I'm saying that x is the number of apple juices. I've called it that here, and I've called it that here. These two boxes say the exact same thing. Plus 150 times y. Well, 150 is the price of OJ, and this box, number of bottles of orange juice, is exactly the same as what I called y up here, number of bottles of orange juice. 1x plus 150y is equal to 15. What's 15? Well, 15 is the total price, and I got that 15 right here. In other words, you've sent somebody out, or you've done it yourself, and you've purchased 12 bottles. And those 12 bottles combined cost $15. You want to figure out how many of them were X, how many of them were apple juice, and how many of them were Y. The way to solve that is to consider it a system of equations. Graph it. The blue line corresponds to x plus y equals 12. Why? Well, use the cover-up method. If I cover up this y, I've got x equals 12, right there. If I cover up the x, I've got y equals 12, right there. Those two intercepts, the x-intercept and the y-intercept, I draw a line through them. I use the same cover-up method with the red equation, and I get a line like that. I find that intersection point right there. I identify its coordinates, 6, 6, and you will find if you plug 6, 6 back in, 6 plus 6, sure enough, is equal to 12, and 6 times 1, which is 6, plus 6 times 150, which is 9, 6 plus 9 is equal to 15. That is the right answer. That is the right intersection of those two lines. Or more importantly, the answer to your original question, how many bottles of each type did I buy? I bought 6 of the apple juice and 6 of the orange juice. That's it. That's the end of this lesson. If you have any questions about any of this, don't hesitate to come into class with them. I'll look forward to seeing you.